Hi, welcome to Intermolecular Forces, Solids and Liquids Part 4. My name is Dr. English. Today we're going to be talking about hydrogen bonding. Specifically, we're going to be looking at what is hydrogen bonding, why is hydrogen bonding important, a representation of hydrogen bonding with fluorine, a representation of hydrogen bonding with oxygen, a representation of hydrogen bonding with nitrogen, and finally, boiling points in hydrogen bonding. Finally, some practice problems at the end. So what is hydrogen bonding? Hydrogen bonding is particularly strong dipole attractions that occur between molecules in which a hydrogen atom is covalently bonded to a highly electronegative element such as oxygen, fluorine, and nitrogen. Here we have 3 examples of hydrogen bonding. So remember, chemistry is fun, F-O-N. You are looking for molecules that have oxygen bound to a hydrogen, fluorine bound to a hydrogen, or nitrogen bound to a hydrogen in order to experience hydrogen bonding. These are the 3 most common molecules that you will see involved in hydrogen bonding on the Regents exam, but other examples are always possible. Why is hydrogen bonding important? Hydrogen bonding contributes to many different chemical and physical processes. These examples include dissolving ionic and polar covalent compounds, holding strands of DNA together like we see over here, the surface tension of water, the structure and function of proteins such as antibodies, and the specific heat capacity of water. Let's look at a representation of hydrogen bonding with fluorine. Specifically, we're going to look at molecules of hydrogen fluoride connected by hydrogen bonds. So let's add some molecules of hydrogen fluoride. So here we have our molecules of hydrogen fluoride. The hydrogen is slightly positive while the fluorine is slightly negative. When we add in our hydrogen bonds, again, we can see that the slightly negative of the fluorine is attracted to the slightly positive end of the hydrogen. And we see this repeating pattern all through this representation. Now let's look at a representation of hydrogen bonding with oxygen. In certain conditions, water molecules will orient to optimize attractions between positive and negative poles of molecules. So let's add some water molecules. Here are my water molecules where the oxygen is slightly negative and the hydrogens are slightly positive. If we add in the hydrogen bonding, again, we can see that the slightly negative end of the oxygen is attracted to the slightly positive end of the hydrogen. The water molecules are oriented in order to optimize these opposite attractions. Now let's look at a representation of hydrogen bonding with nitrogen. Specifically, we're going to look at molecules of ammonia connected by hydrogen bonds. So here's my molecules of ammonia where the nitrogen is slightly negative and the hydrogens are slightly positive. If we add in the hydrogen bonding, we can see that the slightly negative end of the nitrogen is attracted to the slightly positive end of the hydrogen. We've maximized this by orienting these ammonia molecules together so one end is always attracted to the other. Liquids whose molecules are held together by hydrogen bonding, like water, have unusually high normal boiling points. And we can see this by looking at this chart. Compounds that are involved in hydrogen bonding are things like water, hydrogen fluoride, and ammonia. These 3 molecules, compared to the other molecules, have extremely high boiling points. We also know the general trend that as molecular mass increases, intermolecular forces tend to increase, and therefore boiling points tend to increase, which is why we see this general increase in boiling point as we go across the periods. Molecules that contain hydrogen bonding violate this general trend because they are very light, but because they have these highly electronegative elements involved in their compounds, they will have high normal boiling points. Now let's try some practice problems. Which intermolecular force of attraction accounts for the relatively high boiling point of water? So stop, take a moment, look at the answers, choose one, and come back. Welcome back. Let's look at the answers. Covalent bonding, hydrogen bonding, ionic bonding, and metallic bonding. The only possible answer here is hydrogen bonding because hydrogen bonding is directly responsible for the high boiling point of water. Also, covalent, ionic, and metallic are all intramolecular forces. Hydrogen bonding is the only intermolecular force. Now let's look at the next question. Hydrogen bonding are formed between molecules in which hydrogen is covalently bonded to an element having, so take a moment, read the answers, choose one, and let's see how you do. Welcome back. Let's read the question one more time. Hydrogen bonding are formed between molecules in which hydrogen is covalently bonded to an element having high atomic mass, low electronegativity, high electronegativity, large atomic radii. The correct answer here is high electronegativity. Specifically, we're looking for elements like fluorine, oxygen, and nitrogen. All of these elements have high electronegativities associated with them. The table below shows the normal boiling points of 4 compounds. Which compound has the strongest intermolecular forces? So we have HF, CH3Cl, CH3F, and HCl, each with boiling points represented next to them. So take a look at the information presented on the table, pick an answer, and come back and check your work. Welcome back. Let's see how you did. Based off the information given on normal boiling points, we are looking for the compound that has the highest boiling point. Out of these boiling points, HF has the highest boiling point, therefore that has to be the correct answer. HF is also the only compound here that experiences hydrogen bonding as its intermolecular force. So what did you learn? We went over what is hydrogen bonding. We talked about why hydrogen bonding is important. We looked at a representation of hydrogen bonding with fluorine, oxygen, and nitrogen. We talked about boiling points in hydrogen bonding. And finally, we did a few practice problems at the end. Need more help? Feel free to contact me. Have a great day.